everyone, my name is Lauddin Zafar. I am a student at Bilkent University, Ankara. Today I am going to present carbon nanotube transistors. Here is the sequence of my presentation. Here some of the electrical properties of carbon nanotubes have been highlighted, and carbon nanotubes can act as metals or semiconductors depending on their geometry. Zigzag geometry has the option for nanotubes to act like semiconductors. The competitor technologies with CNTs are silicon germanium, strained germanium and 3,5 compound semiconductors, but they have challenges associated with fabrication, tunneling, etc. Some of the properties due to which carbon nanotubes have emerged as promising material to replace CMOS technology are their mobility, ultra-thin body, symmetric transport properties for both electrons and holes, and good performance at low operating voltage and also minimum short channel effects. The first ever carbon nanotube field effect transistor was presented by Decker group 21 years ago. In 2001, the same group presented single CNT based FETs logic circuits, and in 2006, a 5-stage ring oscillator based on single CNT was demonstrated. In 2008, nanotube transistor radios were presented where single wall nanotube devices were used to provide the functionality of audio amplifiers, RF mixers, fixed RF amplifiers and resonant antennas. In 2011, first L-band RF amplifier was fabricated and characterized, and in 2013, a CNT transistor based computer was presented. In some of the recent developments, the realization of a nanotube transistor with 5 nanometer gate length is very important, and this top gate graphene contact FET is different from conventional FET in principle because here the gate is serving two purposes: one, controlling the channel, and other, modulating the drain source graphene regions underneath the gate. In order to fulfill the criteria set by ITRS to make transistor footprint with all components as small as 40 nanometer, Ching Kao and his colleagues presented such a device. And also the fabrication of a 5-stage ring oscillator was presented by research group at IBM Thomas J. Watson Research Center, New York. So to conclude with, the CNT FETs have the potential to replace silicon-based CMOS technology below 7 nanometer node. Thank you very much for your attention.